and precision. Accuracy and precision. Precision means you are on point. You are not guessing. You understand? I said it is A. Okay, that's precision. Accuracy and precision. The second one is cost efficient. The third one is time saving. Then we have safety assurance. Then we have complex system management. I don't care who you are. Do you understand? I don't care who you are. I don't care whether you're a professor or a doctor. You cannot just use your brain to tell me what the fault of an hybrid motor is. I don't care what kind of electrician, whether you're a guru, you're a wizard. You cannot just come and stand and tell me this electric car, this is fault. It is not possible. It is not possible. That's why we have the fifth one. Complex system management. 1, 2, 3, 4, 5. Complex system management. No matter who you are, you cannot tell me a Tesla is this is what is happening to a Tesla. Who are you? When even the button, every button on a Tesla has an ECU. Everything on a Tesla has an ECU. So you cannot come and tell me, yes, I know it, I know the fault. No. It's a complex system. So the only thing you can use to solve the problem of a complex system is optimal diagnostics. There's no two ways about it. Then we have environmental responsibility. That's when we talk about emission. You get? That's when we talk about emission. Depleting the ozone layer. As in when the car is bad and it's looking towards smoke, affecting the ozone layer, well, we have a protocol that was designed way back. No car can be built without OBD2 again because of emission. And that's what we're about to. That's what about environmental responsibilities. Environmental responsibilities. That's what we talk about emission. Every campus has very reduced emission. Most of these only here. Now we have customers' trust and satisfaction. Customers' trust and satisfaction. Imagine somebody going out, looking for how to fix his car. He comes to your place today. You just come, okay, you're welcome. Oh, yeah, connect the car. Oh, that's what's wrong with the car. Bring the part, we'll fix it. Okay, sir, have a nice day, sir. He goes. He comes after 2 weeks again. Oh, yeah, scan it. Okay, sir, see what the car is showing, sir. Oh, yeah, send for the part, fix it. He fixes it, he goes. Where do you think he will go the third time? He'll come to your place. Because you don't waste his time, you don't waste his money, you are accurate. Are you getting my point? He's enjoying himself. Unlike one, they will say, okay, let's go and buy this, they don't buy like 10 different parts. It's only, if for some of them, they will even buy different parts and they will use all, but his fault will not still solve. The customer will come to your place. That's what brings about customer trust and satisfaction. Then the last one, preventive insight. Preventive insight. Preventive insight. Can somebody tell me what I'm talking about now? Tell me what I'm talking about now. We discussed it yesterday. Preventive insight. I'm talking to you.
Guys, you're talking about
freeze frame.
Safety.
Freeze frame. We're talking about freeze freeze frame data on a scanner. The one you said somebody told you this girl will have problem in the next 2 weeks. You understand? So you're talking about freeze frame. That is where this one comes in. Preventive insight. That's one. These are the 8 importance of diagnostics. Preventive insight. You guys should not be angry. You know, say engineers will be like doctors too. You're right, Preventive insight. Preventive insight. So that is that. Preventive insight. So these are the importance of diagnostics. You understand? Importance of diagnostics.
What about, for example, you diagnose a car? How can you differentiate the paint?
You see, I like what's happening because you're pushing me to that place. You're just pushing. No, I'm not a question. They're going to, and I'm happy. You understand, but because if I say we should start now, online we only there for. I have it. See, all those things you're talking about. P code, B code, C code. I will break everything, even the ones that will separate. I will separate all the numbers for you. Do you understand? This was the lecture note I used for the Open University students. You understand? So we have it. See the misfiring. You can say I broke P down, broke 0 down, W 3, 0, 0. I'll break everything down. You understand? But I wouldn't want to be there. Then you start asking me all these things I'm telling you. You understand what I'm saying? So let us be going. Let's be doing it together like that. You understand? Automotive diagnostics is a multifaceted process. Automotive diagnostics is a multifaceted process. It blends technical expertise, advanced tool, and logical analysis. It's because of the logical analysis we are here. Anybody can buy a tool. Anybody can buy a tool if you have money. Do you understand? But after buying the tool, after seeing what the car is saying, what analysis do you give for your cars? What analysis do you give? We said, advanced diagnosis is a multifaceted process that blends technical expertise, advanced tools, and logical analysis. Technical expertise, advanced tools, and logic. This is what automobile diagnosis comprises of. Technical expertise, meaning you should know about a car in the first place. Do you understand? You should know about a car in the first place. You can't just go and buy a tool and say, I'm scanning the car. Scanning the car, what are you scanning? What is even wrong with the car in the first place that you want to scan? So you must have technical expertise. Then advanced tools. These are tools that we got ourselves introduced to already. You understand? We introduced ourselves to these tools already. Then the logical analysis. Logical analysis. That's where you are going to. Do you understand? And that's one of the things we do. Now we're taking care of technical expertise, which we are taking care of now. No more about cars, no more about everything. You understand? No more about it. In fact, the whole course is divided into this. We didn't design it. What we designed was different. But if you check everything we designed, it falls under this thing. By module 4 now we'll start logical analysis. And that's what we'll do till module 16. We already finished we finished module 2 today now. Fine. And we're not doing module 3 till next week. We'll start module 3 on Monday. So module 3 and module 4 is for next week. That is when that PPP, all these things I'm showing you will start. So that's it. We're already on the technical expertise. We know almost all our tools. A good good 2. Anybody can get a good 2. You understand? So that's that. Ensuring repairs are safe, efficient, and economically viable. That is just it. Okay. Onboard diagnostic system monitors vehicles performance and emission. While OBD1 and OBD2 shares the same goal, but be different in standard, capability, and technology. You see, we are still going back to our OBD1 still. Let me just make some things going. OBD1 and OBD2.
Is it 1970 to
1970 for OBD1.
And when is
OBD1 is 1980 to 1995. Yes, on the book. The book is telling you 1990. The book is saying 1990, he said 1980, then he said 1990 onward. But the truth is that OBD2 starts in 1996. Do you understand? They were actually sown before 1996. They were actually sown from 1990. And they are not universal. But that was when it happened. You understand? But they didn't unify them, but it was people. You understand? But eventually by 1996, everybody harmonized. You understand? Everybody harmonized and everybody started using OBD2. So it's from 1980 till 1995. That's OBD1. Now I said something. I said OBD1 and OBD2 they are the same thing. Like I was showing you. I said this is OBD1 socket. So I'm doing this. We have a new version. These are OBD1 sockets for old models. These are OBD1 sockets for old models. If you're conversant with cars, you'll be seeing some computer connection ports inside the engine. They are OBD1. Like this inside the engine? Yes, inside the compartment, engine compartment. Yes, you see, not be one here. Only one shock absorber. If you just take the other shock absorber. You understand? Or maybe back up. They are OBD1. Yes, very visible. You just see. They even write it on top Diagnostics. You understand? They are OBD2.
What of the one that has both inside and outside?
That's what we go to now. The outside one is the normal present OBD2 that is universal to all cars. That started from 1996. You understand? The OBD ones are the old ones from 1995 backwards to 1980. And that one we said every car manufacturers have their own type of connector. And they have their own different types of codes. Like I gave an example with Honda. I forgot the name of that Honda now. Honda that we always used when we were growing up. This first Honda Accord now. What is bullet? What is those 19? Big boy is even called. Big boy is good. You're talking of those ones that don't have OBD. Accord number, Accord 1980. 86, all these 86 there, you understand? Allah, Allah was the first baby boy engine now. That was all, and that one doesn't have OBD. So, if under Allah now, she have oxygen sensor problem. You know what oxygen sensor is? If under Allah, she have oxygen sensor problem. Immediately you on the ignition. The check light will blink 2 times. Then you stop. Then you blink again 3 times. Under call it code 23. And it means oxygen sensor. Do you understand? So GM call it code 12. And it means oxygen sensor. Do you understand? But the different code, but the same fault. But they are all now GM number. Once you on the mission, you see the check line will come once. Then to go, then to come 2 times. That is when you know your car has oxygen sensor problem. Because how many people want to be knowing that? How do you want to know? How many mechanics even know what I just said now? Do you understand? So those are manufacturer specified codes. Those are for OBD1. I'm going this in depth because you have to just understand what I'm saying. Then you see from 1960 now. OBD2, universal for everybody. Oxygen sensor is the same thing for GM, same thing for Honda, same thing for Toyota, same thing for everybody. Then, like before we go further, like I said, but before we go further, the reason why I say have all these sockets is because we come across some cars that you try to do something on the OBD2, but it won't give you what you want. Okay? Do you understand? Like now you can't program OBD, you can't program any old Benz from OBD1, from OBD2. You have to go to the engine where that round thing is. Then you socket this thing on that round thing. You don't connect this to this through the adapter. I showed them the adapter before you came around. You can always have an adapter to connect this one to make it OBD2. Okay. To connect OBD1 to make it OBD2. I don't know. Connect this to the engine compartment. Then this will go to here. This will go to this. The VCR. That's all. So I can always check any Toyota that is OBD1. Understand? So that's the issue. I was going somewhere initially. I said OBD1 and OBD2. OBD1 and OBD2. There are differences. There are differences. OBD1 and OBD2. They are different in 3 ways. The first one is standardization, capability, and technology. That's the difference between the two, OBD1 and OBD2. Now let's go through this. Standardization. Manufacturers specify, each automaker specify their connectors, they specify their code, and they specify their protocols. That's for OBD1. Each car manufacturers from 1980 to 1995, each car manufacturer specify their connectors, and they specify their codes. You understand? And they specify their no universal rule. It's just between brands. There's no rule, it's just between brands. E.g., all GM, all Ford, all Honda. That is that. Then the OBD2, it is federally mandated. That was talking of standard now. This one, there's no standardization in OBD1. But OBD2, it is federally mandated. It is a standard. You must put it. You understand? Then there are uniform, we have uniform codes, we have uniform connectors, and we have uniform DLC. We have standardized strong code for OBD2. That is for standardization. When you talk about capability, OBD1, basic monitoring, focus on emission and critical system. OBD1 will not focus on the emission, and whether it is bringing spark or it is not bringing spark, or it is bringing nozzle or it is not bringing nozzle. You understand? While OBD2, it monitors comprehensively. It can even give you instant data stream. That is the capability of 2 of them. You understand that? Limited data on OBD1. It has limited data. While OBD2 has full data. It reads everything on the car. You understand? Then there is no real-time data on OBD1. As in real-time data, you want to know what this thing is saying. No, OBD1 is not possible. Like we will connect that and that was So that's that. Then connectors, we know the difference between the connectors already. We explained all those ones already. The connectors for OBD1 is 16 pin. 16 pin connectors, constant, nationwide, mandated, federally mandated. And we spoke about the this thing already. Yeah, the 16 pin. 16 pin. Direct 16 pin.
Thank you.
No, let me add you to the first. The communication on WhatsApp. I'll add you now.
Then another thing, talk about technology. The technology of OBD1. OBD1 stops emission, but it can't stop everything. It's not that smart, it's not that perfect compared to the OBD2. You understand? So I think that's that. We will. Let me see. I think that's that for now. Any question? Let's take questions now. At 12, we'll go on break. Then we'll resume for 1. Any question so far? Any question?
Yesterday on module 1. On module 1, we talked about, on module 1, just go, be going on. On module 1, we talked about the, um, we talked about the stages of OBD. We started from the stages of OBD, and we said prior to before 1970, in fact, we started by discussing what automotive diagnosis is. We said automotive diagnosis is the process of identifying, analyzing, and troubleshooting vehicle issues, especially within electronic and mechanical systems. Then we went as far as to talk about the core principles: accurate data gathering, stepwise troubleshooting, cause and symptom testing. We went further by talking about the history and evolution. Went further by talking about the history and evolution. By history and evolution of automobile diagnostics. That was where we went, and we started with. We said from 1950 to 1960, the diagnostics was through repair manual and basic electrical testing tools. Then we said from 1970 to 1980, introduction of electric fuel injection. 70 to 80, introduction of electric fuel injection and the first onboard diagnostics. Don't forget, from 1950 to 1960, it was just based on intuition. Mechanics intuition, electricians intuitions, you understand, their experience, then sound and vibration. Those are the things they use in diagnostics way back. Then when it gets to between 1970 and 1980, with the introduction of electronic fuel injection was introduced, and the first onboard computer. I explained why the first onboard computer had to be added because of the electronic fuel injection that was introduced. Like we all know, there's no way they will just put electric fuel injection and there will be no control for it because of emission. So they had to put onboard computer. Then from 1980 down to 1995, OBD1 was functional. That was one I said the vehicle system could report basic errors to mechanics. It will actually scan, but the problem we had with OBD1 was because it was particular to every car type. It was particular to every car type. Every car manufacturers make their own connector. Every car manufacturers make their own trouble codes. They are the one that defines their trouble code. Okay, let me give you an example. Like in under Accord, way back, under Accord 95, 94, the one we used to call under Accord, the first under Accord that came out that doesn't have OBD port. If oxygen sensor has problem, the it's funny, but that is how it is. If oxygen sensor has problem in that car, it's under will give you code 23. And do you know how you manufacturer certified code requires brand code? It's to give you code 23. And do you know how you know the code 23? I'm talking of under 1994, 1995. That was before the days of baby boy, before the days of academy. You understand? The first under accord. Uh-huh. If the check light, now listen very good. Way back before OBD, on OBD1, if the check light, if you on the ignition of any Honda, and the check light blinks 2 times, bah, bah, it now stop. It now blinks 3 times again, bah, bah, bah. Honda we call it 23 code. That is Honda. Their old ways. They will call it 23 code because the check light blinks 2 times and it also blinks 3 times. And that 23 code from Honda code database means oxygen sensor. Are you getting my point? Now, for GM will give you code 12. GM will blink once, then it will blink 2 times. They call it code 12 on all GM. It will give you oxygen sensor. Do you understand? So there were discrepancies. There were a lot of wahala. They needed to unify it. They needed to make it a convergence. You understand? That was what now brought about OBD2. Now, oxygen sensor anywhere is P0121, P0 is universal. Oxygen sensor for GM is oxygen sensor for Honda, is oxygen sensor for Toyota. Do you understand? They are all unified. So those are the things we were talking about yesterday. Then we talked about advanced diagnostics that involves software, internet connected tools, online protocol, online monitoring, and all that. Come, where's Jaya? Okay. So that's that. And we went further again to break down the vehicles into different kind of modules. We talked about the engine, we talked about the gear module, talked about all the modules controlling the system in the car. Now today, our module 2 today is understanding vehicle system architecture. It's a very short module. You understand? But I'm backing it up with what we did yesterday because I have a full lecture on what we did yesterday that I lectured the Open University students. You understand? So I'm bringing it here. Good morning there. You're welcome. So we might not necessarily, we'll just run through this vehicle system architecture. You understand? We'll run through the vehicle system architecture, then we'll just go through this. We'll run through this one, unit 4. Though this will come fully in module 4. Then yesterday I told you I was going to bring you sockets for OBD1. These are OBD1 sockets. All of them. You can see different cars with different types of sockets. You understand? Different cars with different kind of sockets. See Mazda, see Toyota, see Honda. You understand? By the time you see it, these are the ones that are always in the engine. You understand, bro? You understand? These are the type that you see inside the engine compartment. These are all OBD1 sockets. You understand? This for Toyota self. You understand? But that one that you have to open one thing inside the engine, very close to the shock absorber. This thing, you just see the. So these are all OBD1. This is for Mercedes Benz. This is for BMW. You know what it is. So these are all OBD1 sockets. You understand? But you know why they gave us here? They gave us OBD1 sockets here so that this was the one I was talking to for Volkswagen. This is for Volkswagen.
Oh, yeah.
These two things that you just to program old Volkswagens. You understand that? So the reason why these new tools are carrying this thing is because we have an adapter. We have an adapter that you can use to convert OBD1 to OBD2. So that in case you come across cars that don't have OBD2 sockets, you just use your adapter straight away. These are another two, but this is X-Prog. This is strictly for key and programming of new model gears. Strictly for key and new model gears. Then these are another two, strictly for cloning. This is the one meant for cloning. Any brain box. Our module today is not large. It's just to know the architecture of cars. So let's just do all these things I'm doing. You get what I'm saying? So this one is for cloning. Don't worry, before we finish, I'll clone a box in front of you guys. We'll copy a box, clone it, then we'll use it to start. Then this is supposed to be an adapter for us, because normally what I do is you connect this here, OBD1 is set, then let's make this here. While you fix this on your OBD2, and you can still read anything through the car. You get? So instead of using OBD2 now, you just use your OBD1 direct. This one will still connect and it still help you read stuff. That's why these adapters are necessary. Do you understand? So that is that. These are OBD1 sockets. And they're actually just very good, because there are sometimes you go somewhere. If yes, this is strictly for EGS, the transmission, BM, Benz, Audi. You understand? Strictly for transmission, BM, Benz, Audi. You understand? Strictly for transmission. Strictly for transmission. The good thing is, one way or the other, no, we will get to see these tools work. You understand? Before we finish this course. If we didn't have them, we'll have been a different thing. We have them. So we'll find a way to see them work. Either through you or through me. Either you bring a problem for us to solve, or me I bring a problem for us to solve. So that is that. I think we are good with the OBD1 socket. We are good with the OBD architecture now. You understand? We can always, they ask us now to talk about the lifespan or the life stages of OBD. We can always discuss that right from 1970. So I think that's fine. So we'll move on. Before we continue, let's go straight to the today's business, which is understanding vehicles system. Vehicle ECU, sensors and actuators. That's what we want to discuss about now. Vehicle ECUs, sensors and actuators. We have ECUs, that's the electronic control unit. It's a small computer controlling specific vehicle functions such as engine, brake, airbags, infotainment, that's the sound inside the car, the display inside the car. Modern vehicles have many ECUs working together. Modern vehicles have many ECUs. The initial vehicles, they only have their brain box only control nozzle and spark. You get what I'm saying? Controls nozzle and spark, controls the firing order of the car. You understand? So when they just put that one alone and the car starts, everybody will start going their own. The car can move. But the present vehicles now, we have ABS ECU, plenty ECUs. In fact, what they did was they make sure there was a computer controlling everything you need to do in the car. Even shifting your car seats. BMW and Benz have a module that control that one. Do you understand? ABS, it has its own control module. Gear has its own control module. In Benz, you have what you call the rear SAM and the front SAM. All of them are control modules. The rear SAM control trafficator, control all the lights, control all the rolling up of window and all that. These are control modules. Older cars have maybe like one, some have two, but newer cars, some even have 30 different control modules. But the problem is we laymen, they just focus on the ECM, which is the engine control module, because that is actually what most people need. Just start your car, make sure it is starting normal, it is not misfiring, you understand? Many people do not care about the ABS. But see, you must care about ABS from any car from 2005, 2006, especially Toyota. Any Toyota that the ABS is not working will not select the fifth gear. New cars use their ABS to know when to transmit their gear. Unlike the normal old gears that are not even automatic, they count the selection of gear by teeth, and the normal VVT, they count the selection by fiber and all that. But new cars now, is the ABS that will tell the brain box that this is the speed I am now. Change. I finished counting one. Now brain box change to two. I finished counting two, change to three. I'm climbing a hill. I can't change gear now. But immediately I finish descending, change. These are signals you get from the ABS that goes to the transmission control unit. You can see they are interwoven. And I told you yesterday, I said what connects them together is CAN, Central Area Network. We have always been hearing of CAN. That is it. It's the CAN that connects ABS to the brain box. It's the CAN that connects tire pressure module to the brain box. It's the CAN that connects, Central Area Network. And that was when we talked about something like 5 volts reference yesterday. And I was telling you there will always be a 5 volt reference that will join everything together. Sensors, yes, and all the actuators. You understand? There's always a 5volt reference that will join them together. And that's called CAN, Central Area Network. But yes, I will explain. There's we've just finished explaining ECU. Then sensors. I'm explaining sensors now. Sensors are devices that measure physical parameters: temperature, speed, oxygen level, temperature. When we talk about the engine coolant temperature sensor, that is the cold start switch. That's a sensor. When you talk about the oxygen sensor, the one that checks the amount of oxygen level, that's a sensor. When we talk about speed, we're talking about the speed sensors on the leg. That's the ABS sensor I just finished explaining now. That's a sensor. You know what they do is that they measure what is happening and send the signal to the brain box for the brain box to react. You understand? The brain box will not answer if it doesn't get any report from them. The brain box will not answer if it doesn't get any report from them. Old model Sienna, if the ABS is not working and the speedometer is not moving, the gear will not select because the brain box is not getting any signal from the speed sensor. It is the speed sensor that will send a signal to the brain box. That is the work of sensors. They gather information and send to the brain box to react. Do you understand? Sensors gather physical parameters around the car: temperature, speed, oxygen level, pressure. You understand? It's the map sensor that checks the pressure of the car. Oxygen sensor checks the oxygen level. Engine coolant temperature sensor checks the temperature level. The ABS checks the speed level. These are all sensors. They check physical parameters around the car and they report to the brain box so that the brain box will know what to do. When the cold start switch, the temperature, when the cold start switch, like the temperature switch now, the temperature sensor now, we call it engine coolant temperature sensor. In the morning, the reason why your car starts one hand, I don't care how new the car is, the reason why the car starts one hand is because the cold start switch, which is the engine coolant temperature sensor, is sending a message to the brain box that I am cold, I will not start. So the brain box will send fuel to the nozzle. The nozzle will do poop, you will not know, and the car will start. Any car that the ECM SCT sensor is not working, it won't send any signal to the brain box. The brain box will not flood the bank with the first fuel, so the car will not start. That car will keep doing hard starting. That is the reason why you have hard starting in cars, that their cold start switch is bad. Did you get what I just explained now? If your cold start switch is good and your engine is cold, you wake up in the morning, if you start the car one hand, it is supposed to start, because the cold start, the engine coolant temperature sensor will send a signal to the brain box that I am cold. Then the brain box now will send fuel to the nozzle. The nozzles will open even without you knowing. Once you on ignition, the nozzle will just do poof and pour fuel on the cylinder. So when you start, the spark picks it and it starts once. After it starts, that is when it will now balance itself. That is how the engine coolant temperature sensor works for the car. Now, let's pick something from here. A sensor is a device that measures physical parameter and provides the data to the brain box. I'm coming to your question. That's why I said we should pick this now. Then now, actuators. Actuators are components that perform mechanical functions based on the command they receive from the brain box. Actuators are not sensors. Sensors send signal to the brain box. Actuators receive signal from the brain box on what to do. Simple, clear, open, straight. Sensors send signal, physical parameters to the brain box. Actuators receive command from the brain box on what to do. Then we have a lot of actuators. Fuel injector is an actuator. Electric motor is an actuator. Valves, they are actuators. What other actuators can we think of? What other actuators? Let's come up. Think. If it's not an actuator, I'll tell you it's not an actuator. If it's an actuator, we'll settle it here whether it's an actuator. Think of any car part you know. Actuators and sensors. Actuators and sensors. This might come up eventually at the end when we want to test ourselves. Think of any actuator. Think of any sensor. But don't forget, actuators receive command from the brain box on what to do. Example, fuel injector, electric motors, valves. Which other? Let me myself think of another actuator. Because this is it. Actuator. Things that receive signal from the brain box. Things that receive signal from the brain box. Things that receive signal from the brain box for them to work. They are actuators. The turtle mouth. The turtle mouth is an actuator. In fact, we even call it turtle actuator at times. A Kickstarter is not an actuator. A tornado is not an actuator. A tornado is a car part. I think a Kickstarter too is a car part.
Without the signal of the brain, the actuator will not.
You understand what I'm saying? A Kickstarter can start without brain box. Hello? Do you understand? A Kickstarter of some cars, you don't need the brain box to start them now. It will kick now. No, it might not start. Master brake is an actuator. The one on the circle, right? Master brake should be an actuator.
So master brake is
Yes. But you know the problem is that it's not all master brake that will be actuator. New model master brakes will be actuators, not old model. Yes, you understand? Their master brake will be actuators, not old model. Old model cars, they are using pressure. They are using vacuum pressure for brake. You understand? So it is the new model that will be actuators. It's the new model that will be actuators. What we are just saying here is this, but what we are saying is there's nothing inside. Admin, our marker is not working. Yes, sensors to ECU, then ECU to actuators. Are you getting what I said? Sensors to ECU, then ECUs to actuators. Thank you, sir. Sensors to ECUs, then ECUs to actuators. That's what we have there. The brain box receives data from sensors like the total position sensor, an oxygen sensor, and command actuators like fuel injector, an injection coil, even coil is an actuator. Do you understand? An injector coil to control engine performance. It's very, very straightforward. Seriously. Sensors give reports to ECU and ECU to actuators. ECU to actuators. We're not going to rush ourselves, oh, because this is automobile architecture. You understand? Once you get this, every other one is more. We'll just be riding on slow. The ECM receive data from the sensors. The ECM itself cannot even perform. See, the brain box cannot perform without sensors. Do you understand? It needs sensors to tell it what to do. And even after knowing what to do, the brain box itself cannot do what should be done. It needs actuators to do what should be done. It's easy. So I think we'll just move away from here. Seriously. From sensors to ECU to actuators. That is how it works. See, even if you like, let it be inside aeroplane. You get what I'm saying? Anything mechanical, anything mechatronics, this is what happens. From sensors to brain box to actuators. Sensor senses it, it senses the physical parameter. It tells the brain box, this is what I'm sensing. It tells the brain box, this is what I'm sensing from the physical parameters: temperature, pressure, speed, ignition timing, firing order. This is what I'm sensing. It sends it to the brain box. Then the brain box will relate this to the actuators to perform the functions. For a very good vehicle performance, the actuators will now start acting. And like we said, example of actuators: fuel injectors, ignition coil, and we even said electric motor, plenty of them like that. Fine. Number two, we are going to automotive communication protocol. Automotive communication protocol. I was trying to explain this to you guys yesterday. I was explaining to you guys yesterday. That was when I talked about controller area network or central area network. You understand? Now, modern vehicles use communication network to allow ECU to exchange information efficiently. The first protocol we have here is CAN protocol. Most common vehicle networks enables robust high-speed real-time data exchange. Typical example of that is the engine control module, ABS, and airbags when they communicate together. How does an airbag function? An airbag functions based on the sensors, impact sensors on the car. Do you understand? You know, there are impact sensors on the car. So when a car jams something, the impact sensor sends signal, not to the airbag, it sends signal to the brain box. The brain box will now release the airbag of the side that the impact sensor was hit. If it's on your right side, you notice either the window airbag or the front airbag of the right side will just pull out. You understand? So any operation you see on the car at all comes from a sensor, and it tells the brain box something. Then the brain box tells an actuator what to do. So for what we just noticed now, but even airbags are actuators. Hello? Are we there? You can see getting simpler. You understand? Even airbags are actuators. You understand? So that is it. And the speed they use in communicating, 1 megabyte per second. As in, it's fast. 1 second, they will have communicated. I have a table here. Showing all the CAN connections and everything. Is on your documents. You understand? But it's just 1 minute. Then the topology is CAN bus. Then the second one is local interconnect network. They call it LIN. Local internet, simpler and low cost. Connect sensors and actuators in body control area. Window control. Then this motor control seats. You understand? Those ones are LIN. They are just local area network. You just communicate within inside the just for seats, just for window. Do you understand? Just for seat, window, some small things inside the vehicle. You understand? That one doesn't have to consign. Maybe it has to go through relay, it has to go through fuse. Just within the car. That's that. Then we have FlexiRay. Then we have K-line. The FlexiRay mainly is used for ADAS, advanced drivers assistance. FlexiRay is very fast. You understand? It's high speed, fault tolerant, bus used for safety critical systems. In fact, I will tell you the FlexiRay is faster than the CAN network. Because you see the FlexiRay, the FlexiRay could be Bluetooth, it could be, anything. Most of these impact sensors you see that work for ADAS, hmm, you don't even near them before they sense it. And very smart, very sharp. Like if you want to enter gutter now without UBN, you start shouting, you see the mirror, you see one thing, you start blinking on the mirror. So they're even faster than central area network. So, but the same thing, they are still saying, they said, okay, not faster, Sha. Central area network is actually faster because this one is 10 and 10, up to 10, as in, no, 10 megabyte per second. You understand? 10 megabyte per second, as in the way it acts, 10 megabyte per second. The CAN is 1 megabyte per second. Yes. Then the K line is just basic to is for ECU diagnostics. So those are the automobile communication protocols. We call them automobile communication protocols that we know. From There's another diagram there that says ECU CAN ECUs. It's easy. Let me put it there. To make it very very easy to get. It said ECU1, ECU2, CAN. ECU3, ECU4. This simple, right? It simplifies everything we have been saying about CAN. It simplifies everything we have been saying about CAN. CAN is controller area network that joins all the ECUs together. Like now, let's say this ECU is ABS. And you already finished gear 1, you finished gear 2. It wants to go to gear 3. Probably you press a brake. The car will still remain on gear 2. It won't go to gear 3. Now you accelerated, you want to go to gear 3. How will the gear brain box know that you have accelerated, you are ready to move? As in to continue your journey. Maybe you had a slow because of one trailer that you wanted to overtake or something. It is this ECU, let's say this is ABS. The speed sensor, we communicate with the ECU. That's the sensor. We communicate with the ECU. The CAN, we join it with the car ECU. The sensor will send message to the ABS. The ABS will join it instantly with the car ECU. The car ECU will send signal to the transmission control module. This thing happen within seconds. I'm on 1 now, I'm on 2 now. Okay, now I'm on a hill, I cannot change. So forget what you are saying. I'm on a hill, I cannot change. What is telling the gear that is on a hill? It is the speed sensor on the leg that is telling you, okay, I was running 100 before. Now I'm running 60, I'm on a hill. I can't change. It is the CAN now that will tell the gear brain box to calm down. You can't change yet because I've not gotten a signal from the ABS that he has passed 100. Central area network or control area network. That's what they call it. The second one, we talked about the lean bus. The lean bus, local. This one is CAN. The other one, we talk about lean. We talk about lean, local interconnect network. Local interconnect network, just within the car. And that one is telling us, that one is saying, okay, lean to window, motors, and seat actuator. Now we have another actuator, the seat actuator. That one that goes seat back and front is an actuator too. So we have another actuator there. Then the FlexiRay ADAS unit. That one is strictly for ADAS to make sure all the sensors are smart. Not that you jam something first before it now start reporting. Do you understand? FlexiRay is strictly for ADAS. Strictly for ADAS. Advanced driver assistant. Mhm. Yes. Yes. FlexiRay is what makes that happen. Now you are getting it. Yesterday we spoke about drive assist. You know, there are two different things. There's a difference between park assist and drive assist. Park assist is the one that helps the driver. You just sit down. You understand? It's once the car sees the small space, you just sit down. Benz have it. I used to have a Benz that had it. In fact, any Benz from 2015 have it. You understand? Then any on Toyota Honda from 2020, most of them have it. You just press the park assist. Once it sees you want to park, you just leave the steering. Your own is just to be accelerating and be controlling the pedal. In fact, it will stop itself. Your own is just to accelerate. Just be pressing the accelerator small, small. It will go forward, go back, go like this, and park itself. Yes, I did it here. Okay, you were not around. Yaya was around. I did it here for the university, open university students. Because then I was still with that car. You understand? There's park assist. In fact, that's the most common one. Drive assist is not common. Do you understand? Park assist is the common one. Any car from 2015, 16, 17, you see them park assist, park assist. Yes. As long as you know it has park assist. You came with your leg up. Okay. As long as it has 2018, 2018 should have park assist now. But you know, these are when we now talk about full option and all those things. Some cars don't come with them. You understand? Then the drive assist is the one most convoy governors used to use, especially the ones that have new cars. You understand? I used to have an E400 2020. You understand? That's the one that has all those things. You understand? If you're driving like this, the person in front, just put drive assist. Seriously, you can leave your steering, just give your hand like this. You can even move your leg from the accelerator. You understand? The sensors in front, the other sensors, but they have already calculated the speed of that one. They have already calculated everything of that one. So they will maintain it. Just like cruise control, they will stay on that position. If that person should match brake, the speed has reduced, but FlexiRay will tell you straight that this speed has reduced. This one too will reduce speed. Do you understand? That's drive assist. That's drive assist. So that is all. Oh, sorry, that's FlexiRay for drive assist. Then the K line is just our normal USB diagnostic tool. Okay, FlexiRay is a communication network. Do you understand? Just like Bluetooth, just like Bluetooth, just like CAN. Like this CAN now is wire. FlexiRay is like Bluetooth. It's just a network. It's a communication network in the car. The connections you have on your phone now, you have Bluetooth, you have infrared, you have Wi-Fi, you understand? Now the connections we have on car are the CAN, FlexiRay, K-line. The CAN joins different ECUs together so that they can function together. Are you getting me? The LIN, that's the local interconnect network, takes care of only the seats and the lining up of windows. Do you understand? Why the FlexiRay is the one that detects sensor that detects wrong blind spots around the car, places you cannot see, is the one that helps with the parking assist, is the one that helps with everything ADAS. Anything that is advanced drivers assist is the FlexiRay that works. They can't use CAN. If they use CAN, the accident will happen before it reports. Are you getting my point? They can't use CAN. The accident will happen before it reports. This one now, as you're just going, let's say this is a wall now. Once you're just going, once you are here, you be hearing, you won't hear it. The car should shut down. But you first hear that sound for a long time, you understand? But it is natural for the car to just shut down once it's about to catch it. There was an example I used last 6 months when we were training them. It was an accident that happened around Kuba Expressway. So while I was coming to lecture, I snapped it. There were like 5 cars. There was a Benz in between, new model Benz. There was a Land Cruiser in between. There were like 8 cars. The only cars, like 3 of the cars, no single scratch on them. And it was a bumper to bumper. It was a bumper to bumper accident, like 6, 7 cars. I wish I could still set my phone there to see the video. But you will see that among all the cars, all the Benz, nothing do them for front and back with that Land Cruiser. So people were asking, how? Why? I said, look at this one. They can't know. Those are impact sensors working. Instead of it, then let's go to power and ground distribution. Go to power and ground distribution. Try your next comment. Let's go to power and ground distribution. Power distribution supplies electrical power from the battery and alternator to the ECU and other vehicle electronics. That's just power, which is current. Ground distribution provides a return path for electrical current to the vehicle's chassis, essentially for completing electrical circuit and preventing faults. The ground is talking about the heart. The power is talking about the current. You understand? The current comes from the power supply from the battery and alternator to the brain box and other electronic components. The heart is a return path for electrical current to the vehicle chassis. Key points: power is delivered via fuse box and relay to protect circuits. A well-designed ground system minimizes electrical noise and ensure stable brain box operations. Modern vehicles use a domain-based wiring architecture to reduce complexity, grouping ECUs by functions and connecting them via central domain controllers and gateways, just like the central network we discussed about. Additional visual, okay, ECU and sensor example. We all know what ECU is. Do we all know what brain box is? Because that's what we're supposed to do. I'm supposed to show you what a brain box is. I'm supposed to show you what a sensor is, but I don't think we need that in this class. But even if we do, we have sensors everywhere around. You understand? You should know what a sensor is. You should know it. Then we know what actuators are. We've explained them now. You understand? Ground is the heart of the car. It's the heart of the car. Any wire connected to the chassis. And let me not lie to you, the heart bar, the ground bar, is just a return part. As in, for electrical currents, if there's any electrical surge, every house will pick it. That's the main joy of art. Do you understand? It complements the positive, it complements the current. You understand? But when there's an issue, the whole problem will run to the art. It's like this thunder resistant. When an issue, everybody will pass their problem to the thunder resistant. That's the art. You understand? So that's just the main function of the art. Power is delivered via fuse box and relays to protect circuits. Modern vehicles using domain-based wiring to reduce complexity. Fine. We all know what brain box is, we all know what sensors are, and we all know what actuators are. Actuators, example, are injectors, electric throttle mount, car seat, throttle body. You understand? Those are all actuators. Those are- Engine control unit or engine control module. So at times we say ECM or ECU, which is engine control module or engine. Okay, yeah, that's true. That's true. Unit, yes, control module. Then this one is unit, engine control unit. It's just confusing. And the reason why it's confusing is American and American and English. American and Britain, you understand? That's their wahala. It's just because of American and English discrepancies when it comes to this their English thing. If not, module, units, it's still the same thing. Engine control module. So that is all. Guess what? We finished module 2. We have finished module 2. So now, mm, mm, okay, 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 sir. Coil and plugs. Plenty. Thank you very much. The course, course is choked, but we'll go that route. I brought my other lecture notebook so that we'll start something. I want to permanent. You see this module 1 and 2, I'm permanenting it in your brain. Do you understand? So even this question you're asking, I've already made out time for it. Here we have done module 1 and 2, fine. And we said module 1 and 2 is supposed to be for the week, and today is Wednesday, we still have Thursday, we have Friday. You understand, fine. I'm going to permanent it. We're going to finish everything about module 1 and 2. You will not ask any question from module 1 and 2 again. You understand? What are the importance of troubleshooting? Give me one. Importance of troubleshooting a car, diagnosing a car. Give me one. What are the importance or relevance of diagnosing a car? Yes, give me one. One. Two. Eh? No, I said importance of diagnosing a car. Importance of diagnosing a car. Another one. To know how to solve the problem. Another one. Everybody is solving the problem. Everybody is doing everything about the problem. Everybody wants to know how to solve the problem. Everybody is just talking about solving the problem. Do you understand? It is actually solving the problem. But there is something we talked about yesterday that you have not told me. And that is the main reason for automobile diagnostics. Cost efficiency. We talked a lot about cost efficiency yesterday. That was when I gave you a good example of somebody that bought a 4 km map sensor. Eventually, it was oxygen sensor we use in repairing the. Eventually, it was oxygen sensor we use in repairing the, what is it called, the car. And you know the funniest thing, the guy called me this morning because he has another BMW, this small BM Mini Cooper. He has another Mini Cooper, so it's possible on Saturday. That's what we even work on, because that one they have bought 6 map sensors too, and I'm just laughing at them. You understand? I was just laughing at them. I'll bring it. We'll use it on Monday.
Because most of the problem is when I was learning my program, that inspired. I remember there was one expert, one brother. Those mechanics, you know what they do? They have to move the air fluid.
They let it remove down. So you think the problem is solved?
But the car was moving, but the rate which the engine required was not there.
And it will be consuming more fuel itself.
Yeah, I can't with them this we noticed that the air fluid, which is the PM matter is called Batronics.
Yes, that's Vatronic now. Vatronic.
Was disconnected.
You see?
So we needed to open the car, that's one thing. We now saw that they removed it without letting it go.
And once you remove the Vatronic of a BMW,
It was so the man was complaining that the car was not doing what he wants. And what is the problem? He was thinking it was doing what.
answer for me. So that it will be, I want us to remain online for those that didn't come around. So that is that. Now you see what I'm going to do, You see the module 1 and module 2, we'll flog it. That material with you is just for reference. Because the truth is, when you see the material, you remember me. You remember what I said about this particular statement. You understand what I'm saying? So that is it. Let's start. Like I said, what are the importance of diagnostics? Everybody said to fix the problem, accuracy and precision. That is what I want us to know. Accuracy and precision. You're going there straight, you're diagnosing straight. This is the fault straight, you're changing it, and the person is going away with his car. That is accuracy and precision. It ensures the correct identity. It ensures we correctly identify an issue, preventing unnecessary part replacements. Preventing unnecessary part replacements. I'm giving an example. Faulty battery, faulty alternator. Imagine you have a faulty battery, but the mechanic is telling you it is the alternator. Imagine the alternator is faulty, but they are telling you it is the battery. In these two situations, if you have the money, you buy the two. Because nobody wants stress. You buy the two. So anyone that works, you understand? But when you diagnose, you don't need to. You will know from the system to tell you the volt of the battery, tell you the lifetime of the battery, and if you tell you, it will tell you, because once you connect a scanner and you see the battery, maybe the battery was 11, then you start going to 12, 13, 14, you know, yes, the alternator is working. Do you understand? You know the alternator is working. So you know, okay, yes, I'm not changing alternator. That's accuracy and precision. Accuracy and precision when it comes to diagnostics. That's one. Number two, cost efficient. By pinpointing the exact problem, it reduces guesswork, lowering repair costs. We have started module 1 again. Do you understand? I've started module 1 again. You understand? It's cost efficient. It's cost efficient. And don't forget, we said diagnostics is, we said automobile diagnostics is the process of identifying, analyzing, and troubleshooting vehicle issues, essentially within electronic and mechanical system. Understanding the foundational principles help technicians efficiently pinpoint faults. What you don't have knowledge about, you can't be active or accurate in it. You must have an in-depth knowledge of what you want to even do first. You understand? Because we are doing this course now so that whenever we come across any car, we are no more circumventing, we are no more guessing. We're walking straight up. You understand? Number one, that's number two, cost efficient. Number three, time saving. It saves you time. I know many cars that, I've gone to many garages, but they will say this car has been here for 6 months. And I will just go there and finish it in 2 days or in just 15 minutes. Many cars like that. If I won't lie to you, most of my customers are people that their cars have stayed for so long. You understand? As a programmer now we really call last. Anybody have already done everything. Then you just go there, papa, they will think you have performed the miracle. No, it is diagnostics and understanding the fundamental, the functional rules of every car. When you diagnose and you have the fundamental knowledge of it already, nobody can tell you any other thing. Even the company that created the car cannot tell you any other thing. Because the car is the one speaking for itself. When I diagnose the car here now, Honda cannot tell me this is what I'm getting is wrong. Because they are not here. I'm the one here. And the car speaks for itself. So let's move. Number 4, don't forget, I said number 1, accuracy and precision. Number 2, cost efficient. Number 3, time saving. Number 4, safety assurance. Safety assurance. Safety assurance. Now I'm giving a small example for this safety assurance. If you diagnose a car correctly, and you solve the issue correctly, you are safe. Okay, imagine I'm giving this example for this safety because this is one of the only examples you have for this safety assurance. You understand? Imagine the car has a brake fault. Then they say, don't worry now, this brake is still good, it will still catch. They didn't scan, they didn't do anything. They say, no, this is not, it's not brake now. Don't worry, let's just bleed it. When we bleed it, it will catch. Then you now bleed it. Now enter the road. And the brake fails. And the car has an accident. That's very dangerous. But with diagnostics, it will tell you whether it is the caliper that is faulty, whether it is the brake pad, whether it is the disc. You understand? Or it will tell you anything that is faulty, or it is the drum, the brake drums that are leaking, or maybe there's a leakage somewhere, or the pressure is not enough to give you all this.
Our problem now is now limited, is now section 2. Let's look at oxygen sensor, broken indomie or blocked indomie. Or tampered indomie. This bank is not breathing well. Bank 2 is not breathing well. Okay, let's see. Search. If you don't have a direct tool that can search like this, you can just copy your code. I taught you how to do search. Just say Lexus, so. Look at what it said for itself. So just set Lexus P219. That's all. Okay. This code means there's a bank 2 air fuel ratio imbalance, indicating the air fuel mixture in the engine bank 2 is incorrect, causing a lean condition, too much air, or a rich condition, too much fuel. Common causes including vacuum, exhaust leak, faulty oxygen sensor on bank 2, a dirty airflow meter. This was everything I said before we went to Google, right? That is logical analysis. That was the last thing. Do you understand? You have to know it. I've never met this fault before. But from what I read, from this code alone, air fuel ratio imbalance, I know my problem now has been limited to just 3 small things. So there's only doing things in it. Look at what he said. A dirty airflow mass meter or issue with fuel injectors. You should get this code diagnosed by a mechanic immediately to prevent provincial damage or error. Okay, now, me that I know I'm using a very strong tool, I can easily eliminate fuel injectors. Okay. Because if any injector has a problem on this car, I bet you it shows. It's a smart car.
Which did not show.
It did not show anything about injector. Fine. I can easily eliminate airflow meter, but I won't eliminate airflow meter completely. I will say let us clean the airflow meter.
I can start from there.
Yes. The reason why I didn't want to eliminate, I can't eliminate the airflow meter. The car raises now. It raises. Yes. But if airflow meter is dead completely, it will not raise. So we cannot eliminate it. You understand? So the only thing now we have to do now is going to be very easy for us. Yeah. Kaje ka kawo mun two. Mu kunce wannan, mu goge shi, mu pada shi.
Okay. This together.
And the truth is that I'm not even suspecting oxygen sensor, because if it is oxygen sensor will show that